Welcome to After Lunch. Everyone have a good lunch? All right, I'm going to try to talk loud so everyone can hear me in the back because I'm going to be a little bit tethered to my Mac Mini, which is a normal occurrence. All right, welcome everyone. My name is Mike Spicer. This is AI may not be taking your jobs, but it is definitely taking your flags. So we're going to talk about a little bit of what is happening in the world of AI as it deals with CTFs, cybersecurity, things like that. So who am I? My name, like I said, Mike Spicer. I go by Dark Matter on the socials. I've got these really weird glasses on because it turns out Mac Minis don't have screens. And these are acting as screens, so I can see my speaker notes and everything right here. Anyways, so talk to me later if you want to learn about some cool screens. I love hardware. I love software. I hack lots of stuff. I do lots of stuff with AI. In my day job, I work for Coalfire with Division Hex, where I work on threat hunting, defensive services, AI pen testing, all sorts of things, helping secure AI and break it for all the things. So. Also very active in a lot of communities, including help with Black Hat, do the knock with Black Hat, along with a couple of goons in the front row. So being in Utah, we like to snowboard, run, mountain bike, things like that. So that's a little bit about me. All right, so let's get into this. So the whole basis for this talk happened at SAINTCON this year. Anyone was at SAINTCON? A couple of you were at SAINTCON. It was a super awesome conference. Happens every year in October. So basically at SAINTCON, they have this thing called the Hackers Challenge. And it's been something I've competed in on and off for probably the last, since like 2013. And there's been many times where I've gotten pretty close to winning that thing. It's also what's called a black badge event, which means the winner of that competition ultimately gets free entry into the conference for life. So there's been some black badge winners among us already, and so pretty exciting competition. Also, the challenge number might be wrong because they add challenges, especially when things get wild. The categories, I think that there might be more categories than 16, but I think there is. And then also points, that point number is what I came up with based off of numbers. I don't know if that's accurate or not, because the way the scoreboard works is every time people solve the challenge, it lowers the point, so it causes a dilution in challenges. So essentially 72 hours of mayhem, and I wanted to answer the question, can humans with AI beat this competition? And so this is going to be a little bit of journey to answer that question. And how good is AI? How good is AI to be able to do this? Because we hear a lot of things, and I'm the type of person that I want to actually see it. All right, so let's talk about the setup, how I see AI, how I use it, and my approach for this competition. Like I said, my whole focus at SAINTCON this year was to go and compete in this competition. And I'm the type of person that I want to fail fast and see if there's like proof of concept if this is actually going to work. So the idea behind this is with my setup is I had a human plus orchestrator, which had workers, also known as agents. Those had different responsibilities. All of those things were tracked into a JSON file to be able to track what the status is, all while interacting with the scoreboard. And you can see there some of the different scripts that I wrote. So we've got like the parallel solver, which launches all of the agents. We have status tracker, challenge fetcher, scoreboard auditor, solve challenger. Basically, I integrated with the scoreboard because things change frequently. So I'm always pulling down all the data, so I have the freshest copy of that data, as well as I'm always auditing and checking everything that's happening behind the scenes to make sure that I'm not getting hallucinations, I'm getting false things. So, and a lot of people were using AI to compete in the competition, and a lot of people were using like ChatGPT and things like that, and just asking questions in a chatbot. Unfortunately, for the type of competition this is, the type of challenges that were there, you needed a bit more beef to be able to do that. So the next part of the orchestration is the rules. And the key with the rules.md, basically comes down to my rules. This is kind of like my approach, how it is. So one of the rules is you got to use local LLMs for a number of things. For local LLMs, I always do like command line and script building, things that I could do quick and easy on my local machine. And then I would use larger LLMs to then do more complex problems. Also, every single challenge, when I had the system pull the challenge down from the scoreboard, I had to analyze it, read it, and then create an approach.md file. That approach.md file, and I'll show you an example of that in a moment, of what that looks like exactly, takes any of the information from the hints, from the text that's there, from the type, the category, all that information, and then it takes a best guess at how it would approach to solve this. So that even includes sample like Python code. I mostly did Python because that's one of my strongest languages, super fast to script, and traditionally when I compete in CTFs, Python's the language that I always use. So I would have it also include some pieces of how it would try to approach, also things about it, like does it have a web element to it? Is it going to be like the potential bypass? Is this SQL injection? Stuff like that. It's going to automatically put that stuff in there. And the other thing that's hugely key is memory. Okay, you gotta remember we're in October, which was literally only a few months ago. What is it, like 5 months ago, 4 months ago? And like nowadays, all of the like Claude Code and all of these different tools, they have all this stuff built in. None of those things were built into any of these tools in October. That was only 5 months ago. It's like things moving so fast in the AI space that some of the things I will talk about, like people are doing and building in, like built in, and it's just happening and you don't even realize it. But one of the key things for agents is memory and keeping track of that. So every single challenge had its own folder, it had its own structure, it had its objects, it had a copy of the web page that it pulled down, and it also had a progress file. And that progress file was its memory. So if the agent died, if it got stuck, if something happened, it would know, and I could pick up and resume from that position. The next thing is you've got to make sure you kill stalled workers. Anytime that something gets stuck or it's running too long, feel free to kill it. Start over. Like sometimes that sucks because you lose context. I know like in ChatGPT, sometimes you run into a situation where it's like, oh, guess what? You've maxed out your context window. Start a new conversation. It's like, wow, I got to start all the way from scratch. And that sucks, but also that could be really good because maybe you were going down a rabbit hole and you weren't getting the things out that you think you should have. And finally, you got to think outside the box. I mean, that's me to a T. I'm literally up here with weird glasses just so I can see my speaker notes, so I think outside the box a lot. Also, one of the big things is you got to have human gatekeeping in the loop. All the flags were manually submitted because I didn't want to be rude and like just let it DDoS the scoreboard because that's out of scope. And also, I wanted to make sure that I would review all the solutions because I want to make sure they make sense before I even submit them. Because in the years past, there was challenges at SAINTCON and other CTFs where if you submit wrong challenges, it minuses points from you. So I've kind of got like this thing in the back of my head, never ever submit unless you're absolutely sure you've got that because you don't know that you might lose points for that. In this particular competition, there was no penalty for submitting wrong solutions that I know of, but yeah, it could be a problem. Also, we've all heard of oh crap, I just forgot his name. Asimov's Laws of Robotics. Did I say that right? I've got my dark matter's rules of AI. So always triple check everything that you're doing before you send out an agent. Like just in my brain, I'm always thinking through what's going to happen, what do I expect to happen. Triple check that. All of the requests are logged. So everything that happens on it, make sure it's logged. It's in a file that I can go review, I can open. Day job, I do threat hunting, and that's one of the funnest things I love to do is dig through and look for needles inside of needle stacks, I think is what you say, Grifter. And also everything through Burp, because I love Burp. Burp's a super sweet tool. It's got a lot of built-in functionality, so make sure anything that goes to the web, throw it through Burp, so that way I can replay it, review it, modify it to go like that. So next thing is I want to utilize tokens efficiently. This was not a Mike spends $1 million to try to win a CTF. This was Mike's trying to use local AI, a $20 Claude Code account, and a $20 ChatGPT account to try to win a CTF. So that's extremely reasonable because like at the end of the day, if you're just throwing money to win, like, yeah, like whoever has the biggest computer is going to win. So, and the most money, most resources is going to win. And that's not fun. You've got to have some elegance elegance to it, so that was part of this, is how do I utilize the tokens efficiently, but also thoroughly. I wanted to make sure that as I was getting close to my usage limits, I wanted to make sure I was maximizing them being fully used and switching to other mechanisms that made sense during that process. And we'll get into a whole breakdown on how many tokens I used and things like that. And finally, at the end of the day, YOLO, it's time to live dangerously. So dangerously skip permissions. Any Claude Code users out there will know this command. Just makes life a lot easier so you don't have to keep pressing yes. Sometimes I just feel like I'm a yes monkey. Why? I've doubled my productivity. Simpson fans out there? Okay, I should have put that meme in here. That was a great one. Okay, so, all right, so a little bit more about the orchestration, setting things up. So the core of this was Claude Code, Sonnet 4. Yeah, that's right, Sonnet 4 is what I used, not Sonnet 4.5 or 4.6 or Opus or anything like that, because it wasn't available, and Opus burns credits like crazy, so 4 was the one I used there. So the purpose of that was heavy lifting, doing things that are complex, and the majority of the things I ran through that. The next one was Quinn 2.5 coder, the 7 billion parameter model. That one's super fast. It can do shell scripts, super sweet. Writes Python code very well. It runs on my Mac Mini that I've got here, which is the 24 gig Mac Mini, which is what I did the entire CTF on that I'm presenting on and created this presentation with. So multi-purpose. And then also I used the GPT OSS 20 billion parameter for local in-depth tasks. So that one used a little bit more oomph to be able to process. It's a little bit larger model. It is quantized to 4 bits, so you do lose some of that precision on that GPT OSS model. For those of you who have used it, you know that it's a 120 billion parameter model, and that takes a much beefier machine to run that. But that's the open source one put out by OpenAI, and that one is phenomenal for general purpose tasks and coding tasks. So if you're looking for a phenomenal local model, quantized 20 billion GPT OSS, it still stands up today pretty well. Like I said, we got the Mac Mini, and of course the X-Real 1 Pros right here, these nice glasses. Hit me up for a promo code if you want to, or a demo if you want to try them out. No, I literally just wore these the entire 3 days that I was doing the competition. Wore them around the conference even, and so it's just super nice. Basically, I've just got a nice screen in front of me. It can go widescreen, it's like 2 big monitors, and I can work anywhere. And a battery pack, so then my Mac Mini turns into my laptop. So I'm not even plugged into power right now. All right, anyways, that's enough showing off my hardware. Let me show you some more about the... So this is the system architecture, kind of a layout of the different parts of the architecture that we've got going on here. So I've got the parallel solver that launches all of the workers. We have 5 workers, and essentially those workers are constantly churning on different projects. The reason why I went with 5 is because I started calculating what the maximum is versus the token allowances I'd had on the $20 Claude Code plan, and the $20 Claude subscription plan, and 5 seemed to be the right number to where the velocity of token burn wouldn't use them all before the end of the 3 days of the competition. Plus, they also have time windows where they lock you out after so many hours, and then you have to wait for a while to reset, so I was taking that into account. So I did a lot of calculation to figure out optimal burn use. So in this case, those 5 workers seem to be the best. Also, I had, like I said, the full orchestration where I was pulling down the Hacker Challenge APIs and keeping all that information fresh, as well as my score, because that was important because things changed quite rapidly, especially for those of us among us who are quite gamified and hold our flags till later. Not looking at you, Professor Plum. And then drop them, and so then you have to go back and start solving challenges like crazy. You also have the cleanup workers, so the cleanup worker is going to go ahead and make sure that you've got all of those processes cleaned up. So here's a visualization of kind of what happens when I was in the terminal watching what would happen. So in this instance, it's launched, I've got the check workers, basically this is 2 consoles in front of me, and I'm just watching just solves happen. I was just watching solves happen. And so it was like blowing my mind. I'm like, this is great. This is the best way to CTF ever. I feel so smart. Don't worry, you get even better. So this is kind of the life cycle of all of the agents and how they're working. So this is the loop that I'm constantly thinking of. And this was kind of really the big epiphany that I had for solving the AI, is taking it from just me putting into a chat box and then getting an answer and then testing that answer to this cyclical process of where I have a dispatch where I'm starting at a process, an agent goes to that process, it checks to see if it's solved. If it does, it goes to detect to see if that's solved or not. If not, it updates the progress, it updates flag information if there was a flag, and then it will alert me, and then as it goes back and then gets recycled and then becomes available again. So then these workers are just constantly being pushed around to be working on all the different challenges simultaneously. And in some cases, I put multiple agents on one challenge because it turns out more agents on a single process, challenge actually increased efficiency, and I was able to get solves faster. So that's a really interesting thing. So let's talk about the numbers. Here's some crazy stats and some numbers. So how did this process do? So challenges solved, was able to solve 34 out of the 63 challenges. The total points I earned, it went from one point, I think I had as much as 7,000 points, but after full dilution and people dropping their points last minute, ended up with about 3,373 points. Was able to do 6 entire full category clears. And one AI didn't do and isn't capable of doing, so shout out to lockpicking. Turns out having some physical skills is still important in challenges like this. Total code generated 43,000 lines of code across 400 plus files. So much code, so much code. And then the first blood, so that was like really my proving this out to see if my hypothesis was going to work. And that was 15 solves in 6 hours, and that was a dopamine rush that was insane to be able to see that and see that this hypothesis and my approach was working. To give you a little bit more of a timeline of how things went, like I said, competition was about across 72 hours. There's that really large one in the middle that's red. That one was a very, very hard and complicated task. We'll do a deep dive on that one in just a few moments. It was hard. It took a lot of effort. I didn't actually spend the entire 44 hours on it. It was about 8 hours hands-on keyboard and AI on processing. But just to give you an idea that how long that one took to solve. But you can kind of see the different challenges as they were solved across and the different categories they were in. Now let's talk about tokens. This is tokens burned over time. So you can't really see it because they're kind of gray in the background, but there's still tokens in between those. The only reason why the orange ones are being there is because those were obscene amounts of token burns without very much payoff. And so over this entire process, over those 3 days, I ended up using 135 million tokens. Those tokens did estimate to have a 95% cache hit, which means if I was using API as opposed to the subscription model, those would be cheaper input and output tokens. There was 11,000 total messages that me and AI sent back and forth between the LLMs that I used. There's a total of 712 tool calls. And just massive amounts of code processing. So to put that in perspective, I was paying for that based on Sonnet 4.0, the price at the time, with 135 million tokens. That's probably puts it around the $100 to $200 range for token burns, is what I would have paid if I was using API costs. But luckily, I was using the subscription, so I paid $20. All right, so let's see the proof. What happened here? So this was the first blood that I was talking about, where I was just super excited to be able to put this through. So what you'll see is time's kind of accelerated here. This is over 6 hours. Essentially, the workers just kind of coming back with flags. And the first thing, I was looking at those flags, and I was like, oh, those are legit flags. This is working. 15 flags in 6 hours. At that time, produced about 1,300 points. Diluted, dropped it down to about 1,283. And so I was like, okay, this is mind-blowing. I've done CTFs my entire life, and to see AI just be able to knock this stuff out so quickly really was enlightening. And then to be able to read the write-ups on how it did it and what it was finding. Some of these things were not just, oh, it was trained on something that did this. It was doing novel techniques to do enumeration, find pieces, to be able to figure out what the solution is. So it was definitely taking things that it knew about and trying those, but it was getting new information and chaining those together to be able to find new novel ways to solve these challenges. Next one was the middleware speedrun. This one was absolutely ridiculous. This entire category consisted of 5 challenges. I was able to solve it in 3 minutes, which blew my entire mind. And in fact, the very last challenge was based on a CVE 2547952, and that CVE at the time would have not been in the training data set for that LLM of Sonnet. So this one definitely had a unique lookup to be able to solve and figure that out for that last one. So this one, like, I didn't even believe it. I thought it was all hallucinations to see an entire category solved. Yeah, that one was absolutely mind-blowing that it was able to do that. So just absolutely insane. Okay, so now let's talk about the one that took forever that I finally solved. This was an RSA crypto challenge. And so to start off, I'm going to talk about my example approach, the approach file that I have. So this is the file. So essentially what happens is first the crawler goes out and crawls the game board website. From there, it then gets processed by that local LLM. The local LLM builds out this file. So it's got the information. It establishes a difficulty. And this one was definitely a hard challenge. Any crypto challenge is usually pretty hard, especially when it's in a CTF and it's a 1,000-point one. You know that's going to be something, require something clever. So it came up with the idea that it's going to look for description hints. It's going to look for some different types of ciphers, maybe vulnerabilities in those ciphers. It's going to look at common attacks, as well as examples of tool use, how to use those tools, different Python crypto libraries, as well as resources. So this is another part where I was able to implement, because this is a markdown file, I can then go in and I can add this. So it came up with RSCTF tools for RSA challenges. I added CyberChef because CyberChef is dope. And then I also added FactorDB, so in case there was things that we could do some factoring on. Those are tools that I've used on previous CTFs, so I wanted to make sure that those were in that file. Also, the hint for this challenge was encryption is involved. Identify the algorithm, look for keys. So yeah, encryption was definitely involved. So the last part of my approach file is it has the connection information. In this case, you're connecting to a remote server on port LEET. And then I have a solving checklist that I put through. So one of the things that when you're working with AI and agents that's very, very important is you need to have a clear path for where it's going and how it's going to do it. Just like you have an employee and you want to give that employee clear instructions on how to do their job, you give them a checklist, a run book on exactly how to do that. So as it's going through, it's going to check through each of those categories. And then also gives us a benchmark of how far we've progressed in the challenge, how much data we've enumerated, things like that. So this is that I talked about previously. I had the progress.md files. So that's my checkpoint files that keeps track of where we are, how we're doing it, and how much, how close we are to a solve. So in this case, this is a snapshot mid-practice. While this challenge was running, and you can see the current status was stuck. We need to rethink the attack. So, because it tried collision attacks with hash length 2, tried collision attacks with hash length 1. It was doing all these things, couldn't figure out what to do. Also, it has some snippets of Python on how it was doing the different Python parts. And then also it's like, well, guess what? The decryption decrypted signature is too short, so we're having problems here. There's a comparison that's failing. I don't understand. And so as kind of the manager, the orchestrator that's overseeing all this, I can go through and I can read this and I can be like, oh, okay, we've tried this, we see this is the outputs, I can look at the log files, so it gives me a better idea. So then it's like, okay, here's the real challenge. We're verifying functions on line 64 using default hash length 8. So that hash length is static, something's happening there, so that's a key little piece of information that we need to know about. So then it's like, oh, well, here's some other approaches we can try. We do RSA signature malleability, blinding attack, small exponent attack, padding oracle, multiple signing rounds. So can we use these different things? So now these are all prompts now that it can automatically use to go after for the next stage. So as it's continuing in that life cycle that I was telling you about, it can continue to process and try these different branches and trees. Now, like as me as the orchestrator, I can be like, well, this is definitely not a padding oracle because of the way it is in code, so let's not try that. That's going to be a waste of effort. So this is where the token usage is there, so we can make sure that we add different comments to make sure it doesn't go down those different rabbit holes. So then there was some key observations that were made that it put into there, like for example, that clean message. Oh, one of the parts of this, I do believe we had the source code file for the thing that was running on the server, if I remember right. So that's how we were able to see that clean message, filter limits only to lower characters. And then my most favorite part was the conclusion it came up with is, this is a 1,000-point challenge with 0 solves for a reason. And this was like probably halfway through the competition at this point that no one had solved it. And I was like, thanks, AI. Appreciate you. To be honest, I wouldn't have been able to solve this one. I think I would have probably spent the entire competition on this one challenge by myself, and maybe have gotten this 1,000 points. So yeah. All right. So with that in mind, let's see. That's the button I wanted. So then here's kind of the journey of it going through the different attacks and just finding fail over fail. The birthday attack, multiplicative attack, and then we had this eureka moment. What if we reconnect to get a modulus with smaller factors? Because it turns out every time it would connect to the server, there were coming out these different numbers that finally made sense. It's like, oh, there's this modulus, and then a factor popped out. It's like, oh my gosh, we found the flag. So rabbit hole after rabbit hole after rabbit hole finally turned into finding the correct one, which was a 1,000-point solve on this one. And I do believe, have to be double checked, I was the first to solve this one, or the first to submit. So, which was super stoked to be able to get a 1,000-point bonus on the board until the second person solved it, and then it dropped it to 500 points. So, and I think 3 total people solved that one out of the entire competition. Let's see, this was incredibly challenging. It was super tough, and it just showed the level of knowledge and depth that Claude Sonnet had for crypto challenges and background, and it saved me hours and hours of reading specs and docs and attacks and trying just random things to try to put this together, which is what I would probably done in a normal CTF situation. And with my guidance, I was able to guide this and help nudge it in the right direction, because there were certain things I definitely knew it wasn't, but I didn't know what it was, and ultimately coming down to that final factor was a pretty neat moment. All right, so, whoa, AI is fixing everything. It's finding all the 0 days, it's fixing all the bugs, it's fixed all your 0 days, right? Not exactly. Not exactly. Yeah, we've got some pitfalls. There was a lot of pitfalls. There's so many takeaways in the pitfalls. So yeah, it turns out agents have some failure modes. There was a challenge under the crypto category again called Rose Challenge. It's based on Pollard's row implementation, which is essentially factoring composite numbers into smaller prime factors. And if you take the challenge at face value and calculate the possible combinations, it would take from anywhere, like I think it was 48 to over 100 hours to compute the answer to that problem. So taking it at face value, that meant that obviously, or you needed a supercomputer, but this is a challenge at a CTF. It's meant to be hard, but not impossible. So there was something there. There was some sort of trick or something there to be able to solve it faster, do something. Like maybe there was a flaw in like the calculations, there was a flaw in the factoring, maybe there was a prime number that you start off with that starts you at a point that gets faster for factoring. And this was just throwing away tokens. This was just 15 plus solve files. I even tried to run this on my GPU cracking rig, and it did not speed it up. In fact, that probably was a couple hours of wasted time of trying to figure out and optimize Roe Pollard's algorithm for running on NVIDIA CUDA, which, yeah, rabbit holes abound, throwing away tokens. This was 4,400 lines of code, and AI doesn't care. It doesn't have meta judgment to know when to cut losses. It's like, what, you want more files? You want to burn more tokens? Sure. And Anthropic's like, hey, guess what? Just use more tokens. Just keep using our stuff. Just keep burning stuff down, right? So that's when you've got to jump in and be like, okay, this is not even in the right direction. Like, we're not getting closer. We're not solving. So that's something that the oversight is really helpful to do. The next big pitfall that I ran into is context loss. When an agent would start, it would not remember all of the things that it had. And remember, this was October, which was like 10 years ago in AI talk. We didn't have built-in memory in a lot of the tools. The memory that was built in was not very smart. So restarting a process would get context loss. So then you go down a rabbit hole, or even producing the exact same code, but with different variable names in that second iteration. So it's kind of wild to watch what happens if you don't give proper context. This is where those progress.md files and those approach.md files were absolutely key to keeping that context and keeping that structure so that every time it's loading that information into that agent with that challenge, so then all that context is there. And at the time, you have to remember too, this was before Claude had even 200,000 K. No, that's 200K, 200,000 context window. I think at that time, it was like 25K was all the context window was in October. So, and if you did use Opus, I think you could get up to 50,000 K. Now we have 200K on Sonnet, and I think it's over 1 million context with Claude with the Opus 4.5. And then I didn't even think about using Gemini, because Gemini I've used on other projects, and my whole goal was to really embrace Claude Code because the agentic nature of it and the functionality, there just was no competitor in October for that. And so, but Gemini had 1 million context window. So that would have been very helpful for these longer context runs. Although during that time in October, if you'll remember, there's this thing called context drift, where if you have too much context, it starts going down different rabbit holes because you're adding too much context. So it turns out too much of a good thing is still not a good thing. So some other pitfalls ran into was hallucinations. Hallucinations were absolutely abound. Before I figured out proper prompting and figuring out some of the memory parts, I started getting things with like flag, not a flag. And it's like, oh, that looks like a flag. Let me go submit now. And then, or it would be like, oh, I found the flag. It's C1D65. And sometimes you can get things like that, but usually it's like, okay, we're getting close, or that needs to be decoded, or there's something more. There's something more there. It's usually very obvious when you have a flag. One other thing that I ran into with hallucinations is in the process of doing my progress files in the beginning, it would be like flag, some awesome flag text here. It would literally put placeholders into the file waiting for a flag to be put there, but then my checker would go through and say, hey, there's a flag there. There's a flag in this file. This one's solved. I'd be like, oh, sweet. I go open it up and look, and it's just like, ah, man, that's not the flag. That's a placeholder. So what I hope is someday in the future, some CTF creators do some fun hallucinated flags that look like they're not supposed to be flags, but are actually the flags, just to really screw with you, because that's a good way to trick your AI, because your AI is going to be like, oh, this is not right, but it really is right. So I like to, yeah, I think that would be a good way to screw with AI. And another one is spirals. I've got some examples to show you of the spirals. Spirals are basically, I kind of think of them as death spirals. It's just kind of like getting out of hand, it turns into a rabbit hole, and then it's just getting worse. and worse and worse and worse until it's just massive. So one of the challenges, Plum, did you make the matrix decoded? Was that your challenge? No? Oh. I don't remember who made it, but it was a really good challenge. Essentially, it was a video, and then it had like a matrix screen flowing through it, and basically, it was just crazy. That challenge generated over 1,000 files, 103 megabytes of data as I was analyzing it. Another one of the spirals that was really interesting was there's a category called forensics, which is a play on forensics, where they provided you some files. There was a little bit of reverse engineering that had to go into that. As it was doing reverse engineering, it was like the final analysis, the final approach, the final summary, and it was not even close. It's like, why are you calling this final? Why are you saying we're making progress, we're doing stuff when you're not? I think that's one of the things, because like some of the built-in training to a lot of AI is be helpful, like do good, make sure that things are positive, so you end up with these situations where it's absolutely gaslighting you when it's doing file names and making you think that you're way closer than you ever are. It's like, no, this is not the final at all. So here's the matrix spiral. So this one was absolutely insane. So the first tests, it was creating these analyzing frames. So it literally took all the frames and generated files out of the frames. It decoded it. There was Chinese characters. There was like random characters. There was numbers. It tried to decode those to figure out if those were them. I don't even know what this was. At the end of the day, like there was all of these different things. It's like, oh, let's submit all of these. And in the end, I ended up leaving it completely unsolved. Because it just became just a massive time sink. So another for CTF creators, challenges that involve videos or things like that, embedding things inside of things. For a human, we can look at it and we can decode and figure out what's going on. We can see through some of this stuff. AI is not quite there yet, because quite literally there was Python scripts that were analyzing frame by frame to try to figure out what's happening there. And like I said, that one was definitely a spiral of wasted tokens, although it was kind of funny and cool to see. So, all right. So what are the key lessons? Some of the key lessons that I had is, number one, local LLMs are incredibly helpful for quick analysis, quick back and forth, quick starting points. You can chain them together with like Ollama is typically what I'm using. Ollama has a very nice programmable API for Python, so you can just interact with it very easily. You can also use another library called LangChain, which then can allow you to do some chaining together of different LLM calls. And so locally, and also the web interface, Open Web UI, I use as well. So between those tools, adding those together just creates a very fast way for me to get answers. This helps me with preparing scripting, doing audits, looking at different things to see if they make sense, helping critique my prompts. Sometimes when I'm generating stuff, I want to make sure that it's as token friendly as possible, so I'll run it locally to see what its reaction is before I send it to a frontier model. The other big win that I found was that parallel execution. Essentially what my parallel executor did is it ran Claude-P with the prompt, and then I made sure it was output format was streamed JSON. So everything that was happening from it was streaming to JSON, so that way it's easily parsable with Python, so then that way I could interact with it, and that's how that check was able to read those things. Also, Claude had built-in tool calling, so it could run shell scripts. I also did run that dangerously skip permissions, because you're in a CTF, so YOLO. That's the way you can get those agents just doing whatever they want. And we'll talk about kind of in the future what they're doing here in a second with some of the updates on that. The other thing is that external memory is super critical. For this, like I said, I use some MD files, just markdown to be able to keep those super easy and basic. In the future, I would probably do maybe a vector database or some other centralized repository that's a little bit faster, because then it can work with the local LLM. Also, you can attach that to the other LLMs that you're using to be able to level that up. Basically, the memory space for processing with code over the last 5 months has like just been increased dramatically, and that's because of context window size has increased, so that's been super helpful, but also people understand how to compact and analyze conversations, so then summarizing that information can be a lot more effective and impactful. Let's see. Monitor relentlessly. It's going to go off the rails. Things are completely off the rails. Like the AI right now, every day I constantly say, this is the most amazing time and the most scary time at the same time. We're literally like just in this bipolar dichotomy of just absolute insanity. Like I love it and I'm like, this is scary. So it's going to go off the rails, expect it. Make plans for when it does go off the rails. For me, for this was backups, making sure that I had code written into GitHub repositories, and I would check that in from time to time, especially on my core things like my parallel solver, things like that. So if those did get updated or overwritten by a challenge, or if I got prompt injected, I could roll back, and so then I could be up and running and still running my core process. Another thing is, turns out on Mac Mini, if you use 100% CPU, GPU, and RAM at the same time, your system just becomes like, does not compute, and it just locks up. So running a massive LLM and a bunch of Chrome windows and Chromium windows, and you've got Puppeteer running in the background, and everything doing all of its thing. And Burp, I don't know, Burp uses 1 million gigs of RAM, so everything was just too much. So I know, we need a bigger one.
Studio.
I actually did get a studio, so shout out Pullfire. All right, so let's talk about how AI dominated and where. So the category GraphQuest, and this is my opinion on how and why I think it did well, is pattern recognition and API fuzzing. I think that there is a large corpus of information inside of specifically Claude and Sonnet for those types of activities, and so I think it's been trained around that. Middleware, again, I think that there is a large amount of public information about how middleware works, how HTTP headers are supposed to be, as well as what semantic bypasses exist. So like there's just massive repositories of different things, so I think that when it saw those types of patterns, it activated those tokens inside of the LLM that just allowed it to, in the case of middleware, just absolutely devastate that category. WebAuth, I think, again, this is something in the world that's just very public. There's a lot of information. People have talked about all the different protocols, how WebAuth works. It requires very specific spec knowledge, and it's going to only be applicable to that type of technology that's very fingerprintable, so those are things that it can pick up on. I also think it's very powerful at pwn type things, so this is reverse engineering, so binary analysis, because when you integrate it with existing tools like pwn tools, I also was using an MCP server to connect it to Ghidra to be able to do reverse engineering. It has a large corpus of reverse engineering insight. While it may not know the actual binary opcodes and things like that and be able to calculate exactly how the program is running, it can take that information, especially with Ghidra, and turn that into that higher level like C language, not exactly C, but the pseudo C that it generates, use that to find logic analysis that allows us to solve those things faster. Where I think that human AI partnership was super valuable was like in crypto challenges, because AI just wants to throw every possible combination at it. I was able to help guide it, manage those iterations, and so in the end, able to get back to and give it ideas to be able to get it back to where we were able to get those solves. Blockchain, that was another big one. AI in this case wrote the exploits for the blockchain category options that I solved. But I had set up all the tool chain and all of that. Some of my background was in blockchain analysis and worked doing some Web3 security stuff years ago. And so like I knew what tools to use, what things to build out, so then I wasn't wasting time having it do that work for me. I already knew how to begin that, and so it could immediately start interacting with the chain. The reverse engineering, the WTF categories, so this is just like random madness. There was one challenge that was called, it was an Among Us character. it was about 8 levels of obfuscation that was just packed over and over and over, starting with just the most insane things and ended up in JavaScript. And it was based on an example. The creator of that challenge said that they saw in the real world of malware being wrapped multiple times and obfuscated to get past web application firewalls and endpoint detection. And so it was really clever at being able to do that. AI was able to do that static analysis, but I had to guide it for deobfuscation because I could see what the output looked like, what parts, and the AI absolutely fell. There was a red herring that redirected to a Rick Astley video, famously enough. And it's like, oh, the answer must be at the video. And it's like, no. Trust me, it's not there. That is, I know a thing about getting rickrolled. And then ultimately the human required parts, lockpicking. When are we going to see an AI lockpicking lawyer robot? This is the lockpicking lawyer, and I AI'd your system today. Yeah, I don't know. I don't know when we're going to get that yet. Hardware hacking, again, soldering while connecting wires. Like, I know robotics is getting super close, and there's a lot of AI robots that are doing some cool things, but a lot of those AI robots are being piloted by people on the back end. Spoiler alert. And then I think strategy and triage, I think it's being the overseer and seeing what's happening. And then the vast experience I've had with CTFs, I think, allowed me to point it in the right direction. And ultimately, the entire competition came down to a head-to-head between me and Q, who's here in the audience here. And the final winning factor that pushed me over the edge to be able to win this CTF was, in fact, that I had picked a lock slightly faster than he had solved the final challenge. And so at the end of the day, it was humans that won the challenge, not the AI. So I think that's kind of poetic about this whole idea, process, and putting this all together of trying to see what human plus AI can solve for this. And in the end, it took a physical challenge to actually succeed at the competition. So what does the future hold for us? Like I said, things have changed since October. It's been 10 years in AI time. We're getting better models. They're more capable. We've got wild tools. And oh my gosh, OpenClaw. Who's OpenClawing? Any of us clawers out there? Wow, there's like, I don't know. I just made it up. So let's talk about some of the things that are happening. So Claude Code currently, like, they're doing crazy stuff. Claude Code was like revolutionary. It was like a side project for one of the employees, and then they released it, and now it's like a phenomenon. So if you're not using Claude Code, definitely go check it out. And what have they done since then? Well, they've added this cool thing called Cowork, where it's essentially doing what I was doing, launching multiple agents to go work for you. And they even have commands where you can Control B and put stuff in the background as you're running it, and you can do the exact same stuff that I was doing in October now built into this tool. So it's really cool to see this pattern of execution and reusability being built in natively into these tools. However, provided, let's see, this tool is proprietary. We don't know everything that's going on with it, Anthropic only, and we don't know a lot of the pieces of how it works. So people were like, let's go open source. So there's this really cool tool that came out called OpenCode. If you haven't played with OpenCode, it is phenomenal. You can use it with local models. You can use it with Claude. You can use it with Sonnet. You can use it with Codex. You can use it with a bunch of other stuff. And it's like completely open source. I started tearing apart the core of this to try to figure out how it works because it is very clever. It's got a bunch of harnesses, super cool. So my next projects will be definitely built around, if not on top of or forked with OpenCode, because I think that there's a lot of really neat stuff happening in OpenCode, as well as a GUI too. So they've got a cool little desktop thing. So I'm super stoked about the OpenCode. Next up, there was this really cool framework called Pi. It's a Pi automation framework known as the shitty coding agent. Essentially, what happens is the idea of we want to run agents and have them run LLMs and process over and over and keep going is being noticed by a lot of people. And it created a situation where there's this concept called Ralph. I don't know if you guys heard Ralph Wiggum. Essentially, you just continue and run a process over and over and over and keep it going and throw more agents at it. Essentially, you're putting a while loop around Claude Code. So even when it exits, you just take its output and throw it back in. Well, this guy created a whole agentic system around it. Well, what's crazy is Another guy took that system and created OpenClaw. So he actually built the entire OpenClaw around it, because what Pi didn't have was Telegram. He wanted to be able to, maybe be out away from his computer on his phone and still interact with his code agents. That was his inspiration for building OpenClaw. So now you've got just OpenClaw, which its whole idea is we want to run as much AI as we can with agents and everything all by itself, where you can interact with it from any interface and it can interact with any service. And it just blew up. It got super viral, so it's kind of crazy to see that project just go skyrocket. And also, local models are insane. Like, this is the democratization. You can run this on your hardware. Yes, you have to pay some up front, but models are getting better and better all time. Like right now, Quencoder 3 is within 10 points of being verified as a frontier model, and you can run that on a $3,000 system. So that will do probably 90% of what you are doing with frontier models locally, which then gives you privacy and security of not putting your data out into the world. So in my opinion, I think the future is absolutely going to be agentic. It's going to be model agnostic, and I think we're going to see more increasingly local models. So we've got Claude Code, OpenCode, Pi, OpenClaw. So what's going to be next? What is the next thing that's going to be firing? I don't know. I'm excited to see what it is, but I think that the ideas that I had at SAINTCON, the things that put together for the CTF, really came down and put things together in such a way to where other people are noticing the same behavior, and it's validated by these different projects that are doing very similar things to the things that I'm doing, and I'm just going to continue building out, and I would recommend all of you guys play with these toys, figure out what's up with them, how they work, and make them work for you, because they may do cool things. And on top of that, last night I decided to take OpenClaw and have it start competing in the CTF, because I was like, let's go. So if you want to come check out how my it's called Dark Claw on the scoreboard. He's not scored too many points yet. He's getting kind of lost. I haven't given him a ton of guidance. So you can literally just take your OpenClaw and point him at the website and have him start competing. So sorry, Waylon. So yeah, and with that, thank you very much. I don't know how much time I have for questions. I have 5 minutes. Sweet, 5 minutes for questions. If anyone has questions. I couldn't see, he's in dark in the back. I can see everything. I can see most things. Questions? I've used it. Actually, like one of the key projects I'm working on for a day job, I've been building out a fully functional framework to augment humans for base level, like tier 1 pen testing. So like, how do you look at a specific scenario of scanning, initial findings, low level stuff, kind of think like Oxbow, but like the tier 1 of, not Oxbow, Expo, of what Expo is offering, something similar to that. And so on top of it, we at Coalfire have a lot of pen test findings, and so I've been using our past findings to be able to use those as threat intel for future things that I'm working on. So trying to be more threat intel guided, and then build playbooks, and then automate, and then ultimately level up our testers so that testers can be working on fun projects, hard things, find those hard to solve problems, because that's where I think humans are going to be the most impactful, is very complex business case logic, business logic errors in applications that AI probably will never find because it doesn't understand the context of the application like a human mind can find. So, other questions? I've thought about it, yeah, John. Absolutely. Yeah, like, because as soon as people, initially I feel like a lot of people are like, okay, like let's try it and test, and there's a lot of mandates to use AI across all sorts of orgs, and then sooner or later it's going to catch up, and it's like, okay, what's our data flow? And as soon as you start seeing data flow, it's like, oh, like people are freaking out. So some people are like, well, it's all in Bedrock. It's on AWS Bedrock. And I don't know if you guys noticed or read the agreements. A lot of things that are in Bedrock aren't actually running on Amazon. They're actually farming it out to another company. So there's a ton of models that are Amazon Bedrock models that are not ran. I believe the company's called M2 or something like that. They got the contract to run a lot of models. So anything that's not an Anthropic model isn't running local at Amazon. So that's going to create some very sticky situations for people that are like, well, it's in AWS and all my stuff's approved to run in AWS. So I don't know. I think we're going to have some really big nightmares coming up in the future of people understanding their data flows. So very quick. With that, I think I got time for one more quick question. Fire question. Any others? Awesome. Thank you guys so much. Appreciate y'all.